Good morning, everyone. Participants and our expert, Mr. Manish Gupta, who is presenting today's webinar. It's our 58th webinar on smart and sustainable power system. I warmly welcome on behalf of National Federation of Engineers for Electrical Safety for this wonderful webinar that will take place. So I would like to say a few words about our organization and then briefly introduce our speaker and touch upon the subject. Then I will present this, hand over this to the presenter. See, you are all aware that National Federation of Engineers is fighting for a better tomorrow towards achieving an electrical accident-free India. You are all aware that to make every installation free, we have a mission and vision. We have a vision to make the installation free of accidents, such as electrocution and fire due to short circuits. Thereby, we can increase the reliability of the critical electrical installation. Thereby, we can contribute to the saving of life and property so that we can support sustainable development. To achieve this vision, we have a mission. In this, we want to build a capacity for the professionals who are all involved in this field. So we have a personal certification program for electrical safety by design, installation, as well as the verification. We have started certification course and we are doing it. So to create awareness, we are conducting regular seminars and webinars. This is one of the webinars. In this 58th webinar, we will be having a newer approach on IoT. So this is that thing. Then we have been supported by a lot of members, a overwhelming response within the start of just a 2-year-old organization. And we have a very good response from the members. Now we have nearly 2,000 members, and there are a lot of participants in the webinars getting benefited. So today's webinar will focus on smart and sustainable power systems. This is being presented by Siemens by Mr. Manish Gupta, who is a business development manager, and I am 𝗦𝘂𝘀𝗁𝗍, General Secretary of National Federation. I would like to moderate this session. So the domain expert I will touch upon certain parts if the participants desire so. So I don't want to introduce myself beyond this. So I would like to introduce our today's subject speaker, Mr. Manish Gupta. He has with him a dedicated experience of 17 years in the electrical industry. He is specializing in low voltage systems. He has a proven record in active sales and business development, and his career includes significant tenures at industry leaders such as L&T, and he is now in Siemens, where he has consistently driving growth and innovation. He has a strong expertise in sales. He demonstrated success in active sales roles, driving revenue growth and expanding market share, as well as the business development. He is currently leading business development for infrastructure projects across India. He is leveraging deep market insights and strategic planning. Regarding the geographical versatility, he has experience of working in major cities including Delhi, Hyderabad, Bangalore, Mumbai, and he has a comprehensive understanding of regional marketing dynamics. So these are all his. Beyond this, I just interacted with him. He is having a very good exposure on IoT technical expertise. Why we have device, I would like to say a few words why we are having this webinar, please. See, we know that we are having so many intricate challenges in maintaining an installation free from electrical hazard. So managing and optimizing the electrical facility is an important aspect. Here is the IoT integration getting importance. The IoT will revolutionize the system to a more intelligent way. In this webinar today, we have the opportunity to learn how IoT makes the traditional power system to more intelligent and how IoT can ensure greater reliability by providing real-time monitoring for the predictive maintenance, energy management, and more importantly, the fault detection. With this brief introduction, now I would like to request our expert speaker, Mr. Manish Gupta, to present. Sir, Mr. Manish Gupta, the stage is yours. You can.
Thank you, Apurva sir. Yeah. Good morning, all. I hope I am audible. So, IoT, if I start from here, IoT is what? I mean, it is a device actually which are connected with several sensors, okay, and then it gives a data to the cloud, and that is what actually basically IoT means. I mean, the best example is your, let's say, your smartwatches. Isn't it? It senses the parameters and then it sends to cloud. There is an analysis which is happening, and then it gives uh, uh, a smart output of it, let's say the crux output of it. Similarly, in the electrical system, when we talk about, there are sensors. The sensors will be divided into many things. Okay, we will see it in the subsequent slides. And where it gathers the data and send it to clouds for analysis, and it gives you information which is a meaningful. And when I am talking about IoT, what Siemens has got is Power Center 3000. So, I mean, least I will talk on the, let's say, the product what we have, okay, but the concept of it, I'll show it to you. When I'm talking of IoT, it should be supportive on many devices, not only my device, but also on the many device, okay? So that should be integrated, capable to integrate over this to give the information. And there is a easy integration of these devices when I'm talking of from the perspective of Power Center 3000. Yeah. So it can also give you the lot of information. I mean, information in sense, it is not only about the energy, it is not only about the data of voltage, current, I mean, all those electrical parameters which requires to be seen at one end. Now, this is something I should also mention that this is something wherein I get the data without having any on-premise server, isn't it? This is all information what I'm getting over, let's say, the mobile or the PC, which is connected through a cloud. And that's the benefit. I mean, when I'm actually comparing a EMS, or let's say a energy management system over a IoT system, I am free of any local servers with it. And the information, whatever I give it or take it on the let's say the on-premise servers, I get all those information in here. Now, behind it, there are a lot of analysis which happens. Okay. Uh, Not only that, but also the sensors when it is capable of giving you the information that what I have tripped on. Okay. Let's say, I mean, I'm not only connecting a meter, I'm connecting also the devices, or air circuit breaker or MCCB. Okay, so the information of the MCCB that MCCB is capable of giving it to you will give you the data of mechanics, isn't it? And that information is available on the IoT device. The integration of these devices are easy when I'm talking again from the perspective of Siemens that I have a lot of devices in Centron family, and I get this integration. I mean, without any expert of it that they need to come and program it. It is not that way. It is a very easy way to integrate our own products into it. The supporting of third-party devices with this product, okay, is easier one. Now it is only the data that I have to configure it. Otherwise, there are parameters which are required to be fetched from the devices that I need to configure. Okay, except from this, that power supporting on third-party devices, the other devices of ours can be taken it easily. That's a drop down, which will be very easily done. Now, this device goes, let's say, inside a panel or inside a DB. Okay. Now, this can detect or give you a predictive information, early detection and prevention of downtimes. Okay. These informations will be supportive for the operator to take a maintenance action. Now, IoT device cannot implement on its own logic, or let's say the intelligence to trip on it. It is the information that is available with me. Now I need to know, or I might be knowing well, that what do I need to do with the information that is being captured or given by the IoT device, isn't it? Now, this IoT device, okay, is a component or is a hardware that may go inside a panel, that may go inside a DB if I'm talking in an electrical system. Now, as I have mentioned in the previous slides, that it can be connected not only with the meter but also with the devices, let's say the protection devices, that gives a lot of mechanical information which can be shared through this gateway to cloud. This information, okay, by the necessary analysis which are at the back end of the cloud or the analytics being done, I can have early detection and prevention of downtimes with, let's say, within my panel, isn't it? So that would be helpful when I'm having an IoT device. This will also reduce the frequency, error frequency, and the duration, the time duration through quick localization. I mean, I will be knowing that where the fault is happening, which are the devices that I have to take care of. Okay, so the localization or diagnosis becomes easy. Then on the energy management, when we are speaking basically, so energy management, as we have an on-premises server and that also comply with ISO 50001, is also same here with the IoT device that I am presenting. There's a multifunctionality via the central interface. Okay, this would be the one interface where probably I can connect maximum 124 with this device, where it can all be integrated and give the information on, let's say, on a cloud basis, or it can also have a local visualization as well. That means I'm talking that this does not only become a gateway over the cloud. Via the app you get the information, but also you can log in with the IP address of it, and you can have the local visualization at your premise itself without the need of the software. So these are the things which are there with the IoT device. And one thing actually, the main part probably which I would have missed to communicate while I was gone, I mean because of the network issue. Uh, the device, if I'm speaking of, let's say, IoT, it is not a device which itself is capable of the, let's say, taking an action. It is the information that is being given to you by the analysis, and then the action has to be taken care by the operator itself. Okay, I mean, whether things might be going wrong, so you need to take action over there, that place. Now, it is not a device where we say, I mean, it can give you a support or it can give you a mechanism that it will not allow, let's say, any fire to happen. I mean, nowadays, Mr. Apavu sir will also agree me. Nowadays, we are hearing about IoT microcontroller. Now, microcontroller having a information from the electrical energies, or let's say electrical parameters, will not give a will not give or will not stop the fire incident. There are basically the systems, okay, or the protection device that are there to be in place, like that mentioned in, let's say, NEC of India in 2023, what has been mentioned. Let's say it is also being mentioned by 60364. Now, every device has its own integrity or has its own basis of functions. So that it has to do. I mean, simply having an IoT controller will not stop any incident or event while I am not having a proper thing in place. As I was talking about the sensors, okay, uh, let me start the pointer. Yeah. So these are the devices which this is the gateway. The gateway, the IoT gateway that connects several devices below it. Now these are the field sensor as I speak of. Now this will be in the panel. So let's say these are the sensors, let's say circuit breaker, ACB and MCCB both, for metering devices, for having the energy analysis and all that. This will be connected to the power center 3000. Not only that, but also I can communicate even the downstream devices in the final distribution board. So I can have MCB, I can have AFDD as well, connected with it to give you the information or diagnosis that if it has tripped on certain faults, why it has tripped, and let's say the stamping of the timing and all this will happen, right? And to mouse over it, I can also communicate the fuse as well with this device from this device to Power Center 3000 or via gateway. Okay. Now this gateway can go to cloud, can give you the information that let's say Mindsphere what we had or what we have, and then it can also communicate to different other clouds as well. Now standalone, this device can give you an email notification. Let's say there is a crucial point, actually the energy or maximum demand is being crossed over, or it is crossing the threshold. That email notification can be given, and it can be programmed on such things. Now this can be taken directly at a local place, at your, let's say, PC, or at your let's say iPads, okay, or everything, mobiles, okay. It can be taken on. It can be also integrated hardwire to your PC, and nothing you have to do, that you have to ping in the IP and you get all the information of each and every devices that you will see in the library. Okay. And this can also communicate, this directly can communicate over the EMS software of Siemens. So, I mean, then again, I don't have to actually connect these devices and take it to the EMS, but rather this IoT device is going to help me to take it on-premise data. This Now, when I'm saying about this connectivity, an important part is how actually it is going to get connected. So there are two ways that it can be connected. So one way is that I can connect also over Modbus RTU, and I can also connect, I mean, primarily I can connect this on Modbus TCP/IP. Modbus RTU can be communicated through a gateway, and it can be converted to a Modbus TCP/IP. Let's say I have a device which is a specific device 4200, and it can connect 16, 17 RS485 devices to it, and then it can collect the data through this gateway. So both the protocols, Modbus TCP/IP as well as Modbus RTU, can be connected through or can be taken through these devices to integrate it with the IoT controller. Now, connecting, as I mentioned, I mean, the third-party devices can also be done with it. Okay. Now, the supported devices which are there, which is a drop down, I mean, which is just the pick and drop down of this to integrate it with the POC Center 3000, is all these devices which are there in the family of Siemens. This all can be integrated immediately without the need of much expertise on the, let's say, on the software part of it. Okay. This, as I mentioned, this is a web interface one. So I can see the data at any point of time only by pinging the IP address of the IoT device. And then I can have all the visualization of the consumption, of the errors, of the trippings, okay, all those information from the sensors which are capable to give it to it. Now, this is a small architecture where we have shown that the metering devices to different functions, okay, let's say the ventilation system, heat pumps, all this are integrated to POC 3000, and then it can be taken on the laptop, on the accessibility part. Compliance of this uh, particular device, let's say on the ISO requirement, with the energy measurement, is it complies with the 50,001, 50,003, and all those requirement which are falling under ISO 50,001. So this complies to everything which are a requirement from the energy management point of view. Now, fault localization I have mentioned. Let's say actually you have a sensors which are ACB and MCCB, okay, and it has got a tripping because of certain reasons, okay. So it can remotely give you a data that what is the status information of that, and if it has tripped, that it has tripped on which fault. The alarm indication will be there on the web page itself. Also, you will get an email notification. So it is also easy to localize if something has tripped on a certain fault. Now, messaging, as I mentioned, messaging exception situation, like an example that the energy or the maximum demand is crossing over a limit value, then it will give an email, or it can be programmed for that email. And then it can be also controlled in, I mean, the action can be taken over which the non-critical or critical equipments can be taken in service, or rather taken out of service. The analysis via a web interface, you get the information on the web page of the 10-second measured quantities, which are with the energies, let's say, the instantaneous values of the voltage, the instantaneous values of the current. Okay, there can also be a archiving of those files, and can also be made a download, that what were the energy consumption, let's say, it has done or it has recorded in the past 12 months. So this information can be taken over the web interface. There's a condition monitoring which is available with it. Now, condition monitoring are something with the devices. Now, ACB and MCCB are which probably where we need a change of it if there is a consumption of its complete life cycle, right? So, if the devices, or which are the available, which are the availability of certain features in the Centron portfolio of Siemens, that my device has got a complete life cycle consumption. So I will get a info through this IoT device that this device has got a remaining lifetime of, let's say, 1 year, okay, or 2 years, where I need to change the device. So those information, probably the contact health status of the air circuit breaker. I mean, what do you do with the air circuit breaker? Air circuit breakers are maintainable one, isn't it? So then the information that when the pole assemblies are required to be changed, that information can be gathered over this controller or IoT device, that can give a information that in certain times you have to be prepared for change of the pole assemblies. So these are the informations which are, let's say, for use for predictive maintenance or condition monitoring, that can be given by the sensors like ACB and MCCBs. Now, I have mentioned this, that this web interface, this is a web design for HTML5, and it can be taken on PCs, okay, be it on any kind of web browser. It can be also opened on tablet. It can also be opened on smartphones. Now, the only language not available, I mean, it is not the only English language available with it, but there are other 9 different languages which can be configured with the IoT device. This IoT device can not only be used with the greenfield project, but also it can be utilized in the brownfield project. And brownfield project, the only thing that we need, if it is, I mean, what is the requirement? The requirement, if it comes up with that it is the only analysis of the energy, then I think there are the meters that need to be only retrofitted or renovated, and then it can be integrated with the IoT device. Or if it is also the ACB and MCCB, which are capable of communicating over the RS-485 or Modbus TCP/IP, that can also be taken on in the brownfield project. That is only this hardware that has to be installed in the main PCC, or let's say on any of the distribution boards, and then the data can be taken through it. The digitalization options of Modbus devices that are available with it. You can have all the Modbus devices, I mean, be it on TCP/IP or RS-485, okay, that can be displayed on the web interface in a grouped one. It can archive the data up to 14 months in 10 seconds and in 15 minutes intervals. Integration into cloud system, that can be a third-party cloud or a Centron PowerMind or MindSphere, that can be done. The data are the real clock time. Okay, so in case this is to be time synchronized, it can be done here as well. So all this device which are integrated with it, that can export the 15-minute count values, there can be a generation or archiving of the CVS files. So CVS files you can download and you can access. I mean, it is not again, these are the instantaneous values that are being generated in the IoT device, but these are also stored. So you can easily have the data downloaded, and not only for, let's say, uh, one of the consumers, but can also be taken or compared with different consumers in the same time and the same period, how much consumptions are being happening with those consumers. So when actually we are talking about the data being taken through any of the device, okay, now I am importing the data through the devices and taking it. Let's say I am taking it to the outer world. Okay. The important part of it being is the cyber security. Now, cyber security are something wherein it is now become essential for it. I mean, the data is vulnerable and the data can be theft, or probably if I'm also, let's say, giving a controlling part of it. I mean, people might be requiring monitoring as well as controlling. So controlling part becomes dangerous when it is not cyber secured. So this is all done for Power Center 3000, that this is secured from every point of view. I mean, let's say the local part wherein I define the user admin and password part of it, the communications are encrypted, which goes to the third party cloud or MindSphere. Okay, there's a continuous vulnerability monitoring. So if there is also anything upgradation requirement with the POC 3000, that the patches will be also given via the COS part of Siemens, where you can have a download and upgrade this like you do it with the mobile. So if I look at or summarize it, okay, so the parameterization part of this device, it's just a plug and operate. Okay, so this is not that hard to configure it and then to connect it. So it is the easiest part with it. The connectivity to the different clouds are possible with it. This is also coordinated with our own app-based cloud, which is a Centron PowerMind. There is a easy integration of Centron and other Modbus devices. There are periodic and spontaneous energy data export per email, so that can be configured. So one communication access for one power distribution, so that can be given in. I mean, it is expandable as well. Notification per email and web interface. There's a easy and quick localization of errors, and transparency of the streamlined power supply are possible with this device. For the application, it can be used for process control, can be used for energy management, can be utilized for operational management, and as well as commissioning. So it also gets connected with a software, which is a power config software of Siemens, and then it can be utilized for commissioning and installation purposes with the switchboard or switch gears, let's say. I'll just show you different pages, probably, if it is there available with it. Let me check that. Okay. So the energy policy objectives, which is a PDCA, okay, that is being complied by this device as per the requirement of ISO 50001. The audit requirements which are there with ISO 50003, this also suffice it. So there is a initial and recertifications that can be taken through this, and I mean, that can be easily taken through this. And the requirement of ISO 50006, there's the energy management system, and with this, I can have the energy indicators or performance indicators, which each of the consumers. Yes. So this is the web page where I get here. So I click on one of the library device, okay, which has been integrated with it. So I get this, that this is the device that I have, which I have clicked on, and I get the consumption of power and total active power. And this is a period of 10 seconds. So I can go as minimum as 10 seconds and as high as 15 minutes aggregation. Okay. Similarly, now the let's say the status and monitoring of the devices which you have connected with it. So if you have a circuit breaker which is connected with it, it can give you the status of it, that whether it is on, off, or tripped. okay, and the usability part of it. I mean, let's say in a year, how many times it was on and how many times it was off. Okay, so there is also a signal overview wherein you get the information that what time the certain circuit breakers or certain meters were not online. Okay, there has been a reconfiguration of or the reparameterization of those devices. So all those information you also get in on the web page. You also get all the functionality at a glance. That you get the alarm. Okay, so if you go in alarm, you will find all the alarms which have been there with the particular devices. The service overview, switching languages, if it has happened. Okay, support and diagnostic, and you can also have a different widgets in the web interface itself. So there are different widgets which are pre-configured. So I mean, you want to have the monitoring of the energy first, okay, all the errors or alarms in the next page, okay, or let's say on the voltage side or the current side. So all those things which you want to pre-configure it, that can be easily done in the web page itself. This I will skip it. Okay, so there is, when I'm talking about the central power mind or any of the let's say specifically here, okay, where we have configured everything with it. So there is a cloud-based energy and status monitoring. So there is a full transparency of your power distribution, and you can monitor it from from anywhere or any point. Yeah. So I was at the point where actually you can have this transparency of data of all your entire system. I mean, on the LV side. So you can have storage and analysis of the data from your power distribution system. You can have the basic templates like a dashboard which shows you actual energy consumption, load curves, and comparison with the historical data that are available within the application. So this all you can do with the IoT device. Now, I would also take a few note at wherein there is a people are talking about the controller, okay, that can give you a protection against fire or protection against, I mean, any mishaps. Okay. Now, uh, I hope you will all agree with me that the fire incidents that are taking place are majorly because of, let's say, the reason for it could be a earth fault. Okay, there is a temporal connections between the phase and the earth. Okay, and there is a arcing happening, and because of which there is a let's say the air given to the arc, and probably this can turn into a fire, right? So a IoT device, which I have spoken of, okay, cannot give you an idea of it, and unless and until you capture that earth fault as a current problem, or let's say as a problem which is there in the system. Okay, you cannot have a arrest of such faults. An IoT controller cannot do that unless a IoT controller is having a sensor which is doing a work of a protection device. So a ACB or a MCCB can always detect that, not a standalone IoT controller, isn't it? Now, these are the causes of, let's say, the arc fault or the accidents which are happening in the entire system. I'm not talking of only the, uh, let's say, only with the panel. I'm also talking about with the final distribution boards assemblies as well. Okay, so there could be various reasons for this, and it could be a frequent causes, or it could be a rare causes. Like I'm speaking about the handling of a panel. Okay, a handling of a panel, just an example, that handling of a panel by an expert or handling of a panel by a rookie or by an immature person can be different one, right? A man made error of, let's say, leaving a spanner in the panel, and I made a mistake of that. Probably that could generate a arc and could lead a fire situation in in the panel itself, right? So this is the reason why fire incidents or arc faults happen. There could be a situation like of overloading or short circuiting because of the voltage quality. Let's say there's a puncture of the insulation, there's a short circuit which is happening. Okay, because of the ambient conditions, because of the operating conditions or the pollution degree. Okay, where I have not selected the device properly. Okay, and then I have landed in a situation where the may happen. And if I am not also doing the service and maintainability of the part or any of the system, I mean, not only I'm talking about uh, the the switchgear, but also of the panels as well. So if I'm not taking care of it, this may also lead to a fire situation. Now, in all this, the IoT controller standalone cannot give the detection and a tripping of it. It cannot save me. It cannot save me if I am not doing it properly. The all installation as per the 60364, or let's say the 17121, the Indian standard. If I'm not laying all my electrical installation as per the guidelines, I have to use, let's say, in case of a wire, if it is a class 2 or class 5, so it is also a defined one. So if I'm not taking all these things right from the planning stage to the commissioning stage, till the commissioning stage, then my IoT controller standalone cannot detect this. Now, there is a false claim which is being made by, I mean, some of the manufacturer, one of the manufacturer, that only a IoT device, it will help me to arrest a situation of a fire accident. I will not allow to have a fire accident. Now tell me how. If I don't have a ACB in place, if I don't have, let's say, RCCB in place, as I mentioned, that the fire may happen because of the earth fault. The fire may happen because of the 100 milliampere or 300 milliampere as well. Apart from what the RCCB is doing of a human safety, the 30 milliampere. Now, if I am not installing a RCCB, how it may save? If I am not installing, now what the NEC has come up with installation of AFDD at a particular places. If I'm not doing that, then how it is again IoT going to save me? And it is the device intelligence or a protection device intelligence that is going to save me off. It is not the IoT controller that only actually accumulates the energy data, and then I do not know how. God knows it happens that it calculates all the parameters and then it gives a command or tripping command to a MCB of 32 ampere, and that is all. So a IoT controller is a device that monitors the data, that gives you a realistic information or analytical information that you need to take action on it. But all the devices which are made of doing the things have to be in place to protect against the entire fault scenarios. I mean, let's say for the voltage quality, I need to have a protection against the surges. So for that matter, I need to have a surge protection device. For a for arc generation, which is happening inside the panel, okay, I need to have a active or a passive method to mitigate that arc, isn't it? We are talking of an internal arc containment within the panel. For for tripping against a overload, short circuit, okay, if it is not a, I mean, a small example of having a closed loop impedance, okay? A closed loop impedance in the planning stage or in the designing stage, has it not been calculated properly? Has it not been taken care by the right device? Then obviously, I mean, it is going to affect the system. So this is all an entire installation that has to be taken care as per the guidelines of 17121, as per the guidelines of NEC and 60364. So this was all about the IoT, which I would be I'm thankful to NFV that the digitalization part of it, what it goes through, and the IoT part, what it is required to monitor and access. Uh, uh, this is where actually these devices play a role, but not in an advanced role where people claim of it that it can save entire things having only IoT controller. Thank you, NFE, for giving me this platform and allowing me to educate or give some ideas about the IoT, what it is. This is all from my side. Any questions, I can take it up from here.
Thank you, Mr. Manish Gupta. It's a wonderful session. So there are several questions raised by the participants. Can you open this box, Mr. Manish?
Yes, sir.
You can also see. Anyhow, I will go through one by one.
Please give example to detect electrical fault at critical areas like ICU, OT, in hospital through IoT device. Sir, there are only again, I mean, there is no IoT device which is capable of having it. Okay, it can only sense the faults, okay, which is being given by the sensors. I mean, still detection device like MCB, RCCB to medical equipment. I mean, I'm not using RCCB to medical equipment. but I am using a insulation monitoring for that system, right? So hospital, when I'm talking.
So regarding the first query, it is already clearly stipulated uh, by the presenter that IoT controller depends on the signal from the protective device. For example, there are no simple protective devices like arc fault or MCBs and switches. So it always requires a manual intervention. You have to provide the required protective devices at each and every circuit as per regulation and the standards, National Electric Code as well as several other product standards also. And you have to design, install, and test. Without doing this, you can't expect an IoT alone can take care of all these flaws. Especially in hospital installation, there is a clear-cut provision in the NEC to have a IT, medical IT system and unearthed system. So unless you provide those things, that IT system itself is having a warning and alarm and tripping devices. So that prompt is already there, that is specified, and it will automatically trip. That gear itself, the medical IT device itself will automatically warn, and then after some time it will trip if the hazard is beyond this rated width. So bandwidth. So regarding this, we don't require IoT for this. It can IoT can send you some flaws, some messages, some information that you can make use of it and have a manual intervention to attend to it. It's an additional thing necessary to support all your facilities and to take some predictive maintenance. Okay, we can go to the next question. So Manish, are you? I think there is some bandwidth issue in Manish. I will answer the second question too. If Manish, if you come, you can answer. Then until such time, I will add. Second question is from 𝗦𝘂𝘀𝗁𝗃. How the IoT is used in protection devices like circuit breakers, MCB, transformer. So it's, okay, he is still searching. He is in a poor signal area, it seems. So
Hello.
second question. Okay, please answer the second. I have covered the first question, sir. The second question we
Yes, sir.
can.
Uh, okay. I am not able to see the complete questions. I mean, I'm seeing
Okay,
only the one.
no, second question I will tell, sir. So something
Yeah.
related to the first question, sir. How the
Hmm.
IoT used in protection devices like circuit breakers, MCB, transformer, etc. How it is used in protection devices.
Yeah. Okay. These are, I mean, for protection of these things, I need to have the capability from these protection devices to give a data. Let's say a ACB, I can have a communication over the Modbus TCP/IP or Modbus RTU to give me the information that when it has tripped or at what time it has tripped and what was the cause of the fault. So these information, if it is coming me through to this controller, then I can have all the integration of it. Now, this will give me the idea that what was the consistency, or let's say what was the majority of the fault that has happened through this device, and this device has tripped on. So probably I can take a diagnostic call on it, or I can take a call on having a maintenance of it. The ACB also giving me the information that what is the health status of it. So probably it will give me also a chance that I would avoid a sudden shutdown or a sudden breakdown to happen with my complete system. Again, I mean, if I have to go and talk about let's say with the transformer, okay, I should have the transformer which is capable to communicate me, let's say, the winding temperature, the oil temperature, okay, or the humidity part of it. So all this information, if it is coming me through from the transformer, then I can integrate this with my controller, and to give a meaningful information, I can do the analysis behind it through the cloud app technology.
Bharat Satija, he raised two questions I will cover. Okay. One is, he thanks the presenter. Please let us know what is the USP of it when comparing from other systems available in market. What's the
You,
USP?
yeah, USP of the system which I have presented, right?
Yes.
Yes. So USP of the Power Center 3000 that is there is number one, that it can communicate, or it can have its own web integrated interface where it does not require any software with it to communicate. Number one. Number two, I can have 124 devices connected with it to give you all the information of 124 devices. It can be a combination of irrespective. It can be a ACB, it can be a MCCB, it can be a meter, it can be a power quality meter. So all this information that can be integrated to it. Now, the another best part of it is that when I am having a web interface, I can have the information connected to it. I mean, let's say I am connecting it to a World Web browser, a World Web interface. Then I can have this information from any part or any time of the any time with me. So I need not to go to go to my panel place, and then I see in the local server that what is the consumption or what is the analysis that is being happening. So I can have this information sitting around in any part of the world and at any point of time. Okay. This
Okay.
is also available with a 14-month storage to the energy part with a 10-second integration or 15 minutes integration.
Right. So another question from the same participant. Highlight the requirement or support needed from client if it is to be deployed in brownfield.
The requirement will be only that the sensors which I need to integrate with this hardware are capable of communicating. So that's the major requirement. Okay. Second is that if it is having a communication capability, I mean, people would have gone with it, a communication capable meters or devices, but they have not integrated it. Okay. I mean, they have not wired it through to a common place. So then in that case, that measures has to be taken care while we need to integrate this to the IoT. So these are the two requirements, major requirements that is needed. And probably the third one could be, yes, third one could be the integration of this hardware to the cloud. Okay, or let's say the availability of the internet within the premise. That how we need to integrate it. That is what it is needed. These 3 points.
Okay. There is another question from one Mr. Bhavanandan Ayyanadar. He also raised this, and I will unmute him. But his question is how to get analog or digital input from field and connected to IoT devices. I have allowed him to unmute and speak. Mr. Bhavanandan, I allowed you to unmute and then speak. You can unmute, and if you want, you can speak. I think
No, analog output and digital input. Okay, I'll tell you the part wherein analog output is required. I think these are from the perspective of the measurement. Let's say there is an analog output with respect to voltage or current. Okay, so this can be integrated via PC or something. Okay, because this IoT control does not any analog output via those devices which are in the panel. Okay. The analog output system is a quite older one, if I say. I mean, specific in the process industry.
Mr.
Okay,
Manish
but
Gupta-ji, Mr. Manish Gupta-ji, your
yes,
voice is breaking. And Bhavanandan he unmuted he will ask. Mr. Bhavanandan here.
yeah, yeah,
Yes, yes.
Yeah, please,
Hello.
yes, sir,
please make your
yes, sir.
question.
See, it is very clear how you will connect the system to your system IoT. The input
Ah,
coming from either breaker or RCB or wherever it is, or
ah.
analog input. How will you convert it to digital, or you will directly connect? How will you do it? Is it different from DCS in instrumentation and IoT? What is the difference? looks same for me. DCS, not BCS. Distributed Control System
Right,
and
right. Huh.
IoT. What is the difference? Looks same.
Yes, yes. Distributed control system majorly being
Yeah.
utilized for your process control, sir. Process control automation. Am I audible?
Yes. Can you hear me?
Hello.
Yes, you are audible.
Am I audible?
Yeah,
Yes, sir,
yeah.
audible.
Clear.
Audible. Please.
Okay. I was saying now the two system which you have said distributed control system. These are being majorly used in the process industry. Okay. Now, when I am talking about, and this is an on-premise solution. So when you are having a DCS or SCADA, you are having an on-premise solution that you will get all the information and probably the mutual actions between the two part of the process, okay, immediately done through that DCS. Now, when I'm talking of IoT, okay, I am meaning to have this information, let's say from the perspective of the electrical part, not from the process part. And then this solution which I have spoken is a cloud solution. It's a off-premise solution. It's not a on-premise solution.
Sketch or a drawing, how you are connecting. Those kind of
Uh,
things are required. So that people will
uh,
easily understand.
One second, so I'll flash it again. The whole discussion or the forum was on the electrical part, not on the process part. Okay.
It's okay.
So
It's
when I'm
okay.
coming, yes. So when I'm coming to electrical aspect of it, so these are the sensors which are being connected to the IoT controller or IoT device.
What kind of
Hello.
cable they are?
They are the Modbus TCP/IP and RS485, the Cat6 cable, and then the RJ45 cable which are there now. These are the cable which are being used, sir.
RS485. Okay.
Yeah, this is RS485 and this is Cat6 and this is Modbus TCP/IP Ethernet cables.
But there is a limitation of input,
Yeah, with the RS485, it is as good as in practical situation 16 or 17 that we connected, but not more than that. Okay, but Modbus TCP/IP, it can be n number, and if n number, let's say 1,000 devices when you are connecting with, you might be needing a repeater with that to communicate the further more devices.
Okay, Mr. Bhavanandana, actually, it's a very big question.
Yes.
We can deal with him.
Okay.
He will post,
Continue. Okay, it's all right. Continue.
he will
Thank you.
post his email ID. You can deal with him and speak in exhaustive manner. Thank you, Mr. Bhavanandana. Now,
Okay.
I go
Thank you.
another person, Mr. 𝗦𝘂𝘀𝗁𝗃𝗁. He also raised this. So many people have raised the question. Please make your queries sharp on that. I am allowing Mr. 𝗦𝘂𝘀𝗁𝗃𝗁. You unmute on that.
Yeah, 𝗫𝗫, good morning and good morning, Mr. Manish.
Good morning,
morning,
please.
sir.
Yeah, please go ahead.
Mr. Manish, very excellent presentation on the topic, very advanced topic of IoT. And incidentally, I am retired from Siemens in 2022.
Oh, okay.
Now, so I don't know whether you remember me. So my question is, while you mentioned IoT itself cannot protect a system, power system. Perfect.
Right, sir.
But I know from Siemens, the days when I was in Siemens, we have a 𝗦𝘂𝘀𝘁𝗶𝗏 panel which has got a capability with a arc flash protection relay. You can protect the arc flash and preventing the fire. So
Right.
I know it is not exactly IoT, but we being in NFE here, fire safety is a very important topic with electrical. So can you throw some light if it's something available on 𝗦𝘂𝘀𝘁𝗏 panel, arc flash protection relay, and then how it works?
I would definitely love to, but I think with the scarcity of time what we have, so I will answer the question. But yes, I will request the NFE team again. Probably this was the most important topic which had to be covered. Okay, and for that I would request Appavu sir and Dominic sir. Let me also give an opportunity to present on the whole safety aspect with the panel and with the distribution system.
That will
That's
be
number
great,
one.
Manish, because
Yeah.
that will be great. Because what happens, NFE,
Mr. Davis, so your query is related to the tripping of the circuit IoT by.
Appavu sir.
One second. That is the crux of this webinar, because we have a lot of inferior devices making a tall claim in the market and luring the consumers. So what an IoT can do is clearly explained. And regarding the tripping by itself, you know that even in this webinar, there are so many bandwidth issues. When audio comes and so it's natural that if anything is cloud-based and we depend on the cloud, if the tripping doesn't happen, it happens within milliseconds. So if
Correct.
it doesn't happen and the cloud there is not, can you
No.
risk your life in the hospital
No.
OT? So that is the thing. Our electrical gears are already proven to trip the circuit within milliseconds. And if there's a cloud and other things, we can't ensure or we can't recommend the consumer, you depend on this, you don't bother about this. That attitude will not be good. Anyhow,
Very right, sir.
we will arrange one more
Very,
just
yeah.
webinar on protection child. Thank you,
Yes,
Mr.
and
David.
okay, thank you.
Yes, sir, tell me, sir. Because
I think sir question, Davis sir question was the arc flash system or the arc flash relays. This is a mechanism, again a protection device with a numerical relay, sir. These are the photoelectric sensors which are placed inside the panel, and then it senses that the incident of arc generating, and before that actually become hazardous, okay, it gives a tripping command to the input device, or let's say the incomer device, to trip the circuits to stop that current to flow. That is what arc flash relay do, sir.
Very right.
Thank
And
you.
then,
Thank you.
yeah, very
Thank
right.
you, Mr. Davis. Thank you.
Thank you.
And another person, there are two more persons they have raised. Mr. 𝗂𝗲𝗏 has not responded to. I am now allowing 𝗦𝘂𝘀𝗁𝗃𝗀𝗏𝗏. Please unmute and speak. Okay, there is no. So we will go to Mr. Mubarak. Mubarak ji, you can unmute and speak.
Hello.
Yes.
Yes, sir.
Sir,
Yes.
audible, sir. I am Venkatesan. Good afternoon, sir.
Yes, sir.
Good afternoon, sir.
Yes.
Good afternoon, sir.
Sir, Manish, sir.
Yes,
For
sir.
this
Yes.
IoT, actually, we are working from government organization, central government organization. For this IoT, internet connection is must.
Right.
Internet connection is
Right.
must.
Right. Yes, sir. Yes, sir.
For separate, suppose you are one connection is any number of devices limitation is there.
Yes, sir.
We
The
are
controller.
we are having in township 12 substations. Suppose we are providing in 12 substation. In one internet connection, can you interlink with all devices, or some extra connections are required?
No, it is actually your I should say it is like a server. So you have multiple switch right now. So you have multiple
Yes.
switch. I mean, through that switch you can have an input and output to let's say the internet.
Even single connection, single broadband connection, we can manage it through internet switches.
Yes, sir.
Okay. Periodically, that payment will be separately will be.
Yes. Now actually it comes
Sir.
the app-based solution, which is a cloud solution. So when you are using a cloud solution, like you are using the OTT platform and all that. Hello.
Okay.
So it is in the same way. I mean, you have to pay a subscription. You have to pay a subscription that will be annual or monthly or quarterly.
Oh, annual subscription will be needed. Okay.
Yes. So, but with this device, you
Yes,
can
sir.
log in within this. It has got an integrated web page facility. So you need not to go for a cloud-based app, but rather with this device itself, only the hardware itself, you can see all the data.
Okay, thank you. So regarding the financial aspects, we can, Mr. Venkatesan or any other participants, we can raise queries to the presenter
Yeah,
directly.
we can discuss one-to-one or something.
Yes, he will post his contact particulars, mail IDs. Okay, I request all the participants to cooperate. regarding financial aspects and other things, you can directly deal with him. So Mr. Venkatesan, you can mute. Then Mubarak Khan, please, sir.
Hi.
Please.
Yes. So thank you very much, 𝗂𝘁 sir and Mr. Manish for arranging this webinar. It was really insightful, and we learned a lot. My question is that we are actually making these medical isolation panels where I want to add the IoT-based alert system for my alarms, which is being generated in the panel. So what provisions can we have, and what is the hardware requirement which will be there, and how much reliable will it be in terms of the connectivity and all that I want to know. So just
Sir, it will be
there will be a NO contact which will come, and we need to alert to people through SMS call or some other signal to the remote system.
okay. So the same hardware can be integrated in there, the medical isolation system, okay, or the medical isolation panel. You can have, if the panels are very nearby, you can have a system integrated in such a way, okay, where this device can be, let's say, taken up with 4 or 5 panels all together, and then it can have an internet system or a local Wi-Fi, okay, wherein you can give a alert via the web pages, okay, or if it can be also taken on the GSM via the mobiles. I mean, via the mobiles network, okay, or via the internet network. So all this hardware output, NONC output, okay, that can be taken into here along with the POC 3000, okay. It will be now depending upon how actually I am making the architecture, and then I can integrate this through the system to give you an alert, SMS or emails.
Phone call is not possible, correct? Yes.
Phone call is not possible. No, phone call is not possible. SMS can be generated, alert can be generated via SMS or via email notification, okay? Or if you are taking it on the, let's say, PC, okay, it will give you an alarm page or alarm window immediately on the PC if there is something tripped or something, some contact change has happened.
Okay. So means if we take on a PC, do we need to buy a separate software, and you have already integrated that?
No, you do not need to. You need not to buy.
So means it is already part of the package with the
hardware.
UI.
Yes, it is the part of the hardware itself. So UI, the user interface which will be there, it will give you all this notifications.
Okay. And do we need one hardware per panel, or a single hardware will be sufficient for all of them?
That architect probably we can discuss offline. See, as I told, there are 132 nodes that can be connected. Okay, 132. I mean, 132 nodes can be connected with it, but then depending upon your the output is NO or NC, correct now? So we need to check it that how we can integrate this to POC 3000 and how many NO NC can be integrated.
Okay. These are all related to the IT side and the
the architect side probably we can discuss. Yes.
Company architecture. You can discuss, Mr.
I'll take help of 𝗂𝘁 sir to get connected with you. Okay.
Yeah, sure.
And then we can further.
Now I request Mr. 𝗦𝘂𝘀𝗏𝗿 Telugu. We also raise his hand. If he comes, we can answer him. Otherwise, we can go for another question, Mr. Gupta-ji. I will go one more. There is one question from 𝗦𝘂𝘀𝗁𝗏 Joshi. How can I get ballpark cost to start an? This is a financial question. If you feel
correct. So we can connect separately on this.
There is one more question. What's the cost of power center? So this,
again,
if Siemens have some stall at Delhi, we can discuss.
𝗦𝘂𝘀𝗁𝗏. Yes. 𝗦𝘂𝘀𝗏, we are also there.
Another query from Muthukumar. Yes. How to make sure that set of standards are followed for electrical safety in R and AC systems? I couldn't understand before. R and AC system.
R and AC system. Sir, if you're there, you can elaborate this question.
How to make sure that set of standards are followed for electrical safety in R and AC system? Muthukumar, I couldn't understand.
Yeah, Muthukumar sir, if you are there on the call.
Not here. You can reply for the other participants.
Yeah.
If there is no number, you can raise. He has not come. He has not raised his hand. Okay, you answer. Otherwise, we can.
No, RNAC system, no, I do not know RNAC system means what. Okay. I mean, for the electrical safety standards,
Yeah.
I mean, the guidelines which are there, that has to be only
Yes.
followed. IS 17121 and then the NEC 2023.
Yes. Okay. So it's already there. We are propagating electrical safety measures through various
Yeah.
webinars. Webinars are covering those things only. The participants can go through our earlier YouTube videos on this subject. Then there is an anonymous attendee. We do not take anonymous attendee. Anyhow, can we use IoT in transfer safety? Yes. Yes.
Yes, sir. Yes, we can do that.
It was already subject to the
Yes.
communicating.
Yes.
Then
Yes. As
another
long
query.
as it is giving me data.
Yes. Another query is from 𝗦𝘂𝘀𝗁𝗍. I'll read. Manish, how serviceability decision is taking place? Is predefined time elapsed basis or on the basis of actual condition of breaker contacts? Example, erosion and contacts or damaged condition can also be sensed through IoT system.
Okay, now these are integral part of the ACB or MCCB when I am taking the contact health status. Okay, these are the calculations which are not the calculations. I mean, these are the actual sensing based on the algorithms that is embedded in the new circuit breaker line, which is 3WT plus, 3WA, 3VA. These are capable of giving me the number of days or number of years remaining with the circuit breaker, be it MCCB, be it ACB. So these are the algorithm which are there, and with this, it is giving the predictive maintenance data, condition monitoring data.
Okay. Same type of question from Subrata Kumar Bera. Can IoT implement for 1000 kVA distribution transformer for LPG bottling plant, and how?
Yes, I mean, it is the same answer. I mean, distribution transformer is a distribution transformer, be it a 2.5 or 1 MVA transformer, and any application. As long as I am receiving the data, let's say the critical data of through the energy meters, let's say, what is the loading that is happening on the transformer. If it is required that I need to check the insulation of the oil, or let's say the insulation of the winding, okay, oh sorry, the temperature of the winding, okay. As long as these data are being given by a particular sensors, I can integrate this through the POC, and I can take this to the web pages, and I can give you the information and take the give you the predictive maintenance ideas over the transformer as well.
Okay. So the same type, but interesting. Asked by Sakradar Kilugu. From MCB or RCBO, how to connect to IoT? Please confirm.
Yeah, yes, sir. So we have the devices MCB, RCBO, as well as the arc fault detection device. These three devices, which go in the final distribution board, okay, can communicate over this particular the IoT device, which I have shown POC 3000. Now, the architect would be a little different one, okay, wherein I would be integrating all these communicable devices to another gateway, which can communicate to you locally on the Bluetooth. Means you can connect via Bluetooth that device, okay. And let's say in the MCB board, you have a 12 number of feeder, 12 number of MCB, and you want to take all the data. You want to know the energy, you want to know the current, voltage, even temperature. You can have this over Bluetooth, and this one gateway will get connected with POC 3000, which I have today shown in our topic. This will connect it to it, and I can fetch the data over the web pages. So all these devices can be connected. Number one, I mean, I have every communication facility like we see in ACB and MCCB, similar like there it is available in the MCB and RCCB and AFDD. Now you want only the contact status, that whether it is on, off, okay, such information. Then also I can have the contact which can communicate on Bluetooth can be integrated on the IoT.
Okay. Thank you, sir. So the specific doubts are raised again and again. The MCB, as per
Hmm.
NEC and IS 732, it has to
Hmm.
trip within 0.4 second
Hmm.
when the fault is persisting. If it
Hmm.
doesn't and it becomes faulty, then
Hmm.
IoT can be of use. Oh, your system has become faulty. By the time IoT sends a signal or prompt or trip the circuit, it will not trip because it was already faulty. So the first
Hmm.
priority is always have your own hardwares first, then go for these additionalities. And it can be
Right.
well informed, no doubt. IoT based system is can well inform you
Hmm.
that how to make intervention. So
Hmm.
you don't have a false belief that IoT will take care of everything unless you give all the parameters. It will work. It will give inform. So
Hmm.
this is my
Right.
another
Right.
another query, Mr. 𝗦𝘂𝘀𝗁𝗶𝗶𝗏. How IoT based system, for example, MCC, is differ from intelligent MCC.
Okay, that's a different question. Okay, and probably we can connect it together. IMCC are part wherein these are specifically for the motor, and this can also be integrated in IoT, which I have mentioned in the presentation, POC 3000. So this is another intelligent MCC wherein we call it as a SIMO code in our portfolio, and SIMO code takes care of the entire things. I mean, entire things related with the motor. I mean, it is as good as if I say it a doctor of motor we check the every healthiness parameters of it and then give me a alert or information that this is going to happen wrong or this is something which is excessive and it will give me a information over IoT.
Okay. So another very interesting question from Subrata Kumar Bera. Can protective relay be replaced with IoT for 1000 kVA, 11 by 0.443 kV transformer?
I think Apau sir, you will agree with me. It is no.
So,
So IoT is a device which is only able to collect the data, analyze it. Okay, it cannot give a precision times. What do you say? Tripping. Okay, a precision tripping. What a numerical relay can do. And numerical relays are also not direct acting devices. These are indirect acting devices. And again, I mean, when I'm talking of the IDMT characteristic, even with the numerical relay with different ANSI codes, I mean, there are several ANSI codes with this. So this all cannot be replaced with IoT, which will actually sense it. And I do not know if my network is there or not there. I mean, like we are facing it today, okay, whether it will be giving a tripping or not. And if it is a slight delay, a split time seconds, okay, or a split second delay, probably will create a havoc in the panel. So it is not an alternative.
yes, it's a good thing to rely IoT as a informative device and forewarn the operator who can manually do something. And it can't be a replacement for relay system because relay itself is having inherent operating characteristics for various types internationally accepted by IEC and ANSI, as you said. So we'll go to the next
Correct. I
question.
mean, it is just an example of a smartwatch or Apple Watch, which can give a information to the nearest hospital that what is going wrong with you, but it cannot operate you. It cannot take an action that you will be cured. It is the
Yes,
same way.
yeah, rightly told. It will not take us to the hospital. We have to go. Okay.
Yes.
Then another question, Mr. Kamlesh Kumar is also our NFE member. Is the systems provide some prognosis KPI apart from current health condition and diagnostics KPI?
No, can you repeat the question, sir?
Is the systems provide some prognosis KPI apart from
Okay.
current health condition, and diagnostic KPI?
I would like to hear
KPI.
it from sir. I mean, who has got this question? I mean, the prognosis, the detail of the prognosis. What else does he need apart from the, let's say, the health status condition monitoring? anything specific that he is looking out for.
Okay. Okay. He's not here. Okay. Another question from Gopal Yadav. What is applicability of IoT in renewable power plant, wind and 132 for 33 kV substation? It's a very broad-based question. Would you like to answer?
Yeah. No, I don't have answer as of now, because when we are speaking of the low voltage side, okay, and not on the, let's say, the 132 kV or wind application or the solar application. So probably I can take this answer. I mean, I can take this question and answer this later on.
Yeah, okay. Thank you. Another query from 𝗦𝘂𝘀𝗁𝗶 Kumar. This query is, many a time we have faced a loose connection on termination points in breaker or MCB becomes a reason of heating, and the temperature can be raised to a higher level of 300 degrees C. This condition
Right.
converts into fire. Do you have any solution for these problems?
Yes, there is now for such situation. Okay.
Yes, yes.
I would be saying that this is the temperature effect which is happening, right? And for such situations, I might be needing to monitor the temperature of the terminal. So let's say there is a circuit breaker, I can monitor the temperature of the circuit breaker, or I can monitor the temperature of the terminal. And with this, I can take a preventive action again. I mean, there is now, had it not been the situation of IoT, what we are today into today age, it was the regular practice in maintenance that people go and open the panel, and in condition they monitor the temperature with a temperature gun, right? So those were the maintenance practices that people used to take. But nowadays, what is happening? Now we have a temperature monitoring sensors. With this, I can integrate those sensors to our IoT device, and I can have the data from right from the beginning of the this thing commissioning to till the time of the till the lifetime of the devices. I can have those monitoring, and we have also installed such installations, such temperature monitoring installations in the industry as well. In the F&B industry, we are doing it. We have done it, and we are doing it.
Okay, it's a very good input it's a learning because it's a major,
Yes.
it's a very important question, and the temperature
Right.
rise, once it is monitored and informed, it will be a good thing for the people, for the maintenance.
100% agreed, sir.
Yes. So we have completed all the questions. One Mr. 𝗂𝗏𝗏 raised his hand. Mr. 𝗂𝗏𝗏 Buddharaj, you can unmute. We can close.
Yes, sir. Yes, we can close the this thing, sir. And probably if someone has got anything related to this topic, please connect with me. I'd be very much happy to help you.
Thank you, Mr. Manish Gupta. It's a wonderful session today. It's a learning for all. Thank you for all your expertise and inputs and answers, all the concerns raised by the people. So we can close this webinar, and we will meet again in the next upcoming webinar. I request all the participants. If anything is unanswered, you can directly contact our admin and get it transmitted to Mr. Manish Gupta, or you can ask directly Mr. Manish Gupta as well. With this, I would like to thank all the participants, and especially our speaker, Mr. Manish Gupta, and our back-end team from Blue and Green. Thank you all. Thank you all.
Yeah, I would like to thank you again, NFE, Mr. Appavu sir and Mr. Dominic sir, for giving me this opportunity. And hope the session was useful and there was a takeaway. And let's connect again. Thank you all, and thank you all participants.